Hello and welcome to Electro Studies. In this session, I am going to discuss important concept on various network theorem, which can be expected for different competitive examination. You may expect in terms of theory part or numerical part. So you need to understand the theory very clearly. So I'm not going in depth. So I'm just giving an overview about those theory so that you can apply in your competitive examination. So my plan of action, I would like to cover Thevenins theorem, Nortons theorem, and a maximum power transfer theorem. These are the theorems I am going to explain in brief. Let's get started about Norton's theorem. So what about Norton's theorem? Sorry, first of all, I would like to discuss about Thevenins theorem. Later, I'll come back to Norton's theorem. Okay. So both are similar. I will tell you how it is very closely similar, how we can able to interpret the various type of circuits. So according to Thevenins theorem, so let me write the statement first. Any two, we can write any two term, any linear two terminal circuit can be replaced. Okay, can be replaced by equivalent network, by an equivalent network. You can write by an equivalent network. Okay, by an equivalent network consisting of a voltage source, you can call it as VTH, voltage source, in series with resistance. This resistance you call it as RTH. That means, so you can write like a two-terminal circuit, a linear two-terminal circuit can be replaced with an equal network comprises of a voltage source series with a resistance like this. Correct? So it's a two-terminal, terminal 1, terminal 2. It is a linear network, right? Linear network. So we can call it as the source as ETH or VTH. Both are fine. This is your RTH. Okay. This is basically called Thevenins theorem. Or you can write the equivalent circuit like this. So you can mark the source. This is your ETH. Mark the polarity, positive, negative. It's understood. So we have RTH. This is your RTH. And you can mark the load also. This is your load. Like that you can mark. This is basically called Thevenins theorem. So whenever you are solving some certain problem, and you can apply the Thevenins theorem. Voltage source, the series with the resistance, that you can remember. Okay, I think it's clear to all. Now I would like to discuss about Norton's theorem. So anyway, you're familiar about Thevenins theorem, no? Then Norton's theorem, that is very simple. Here, I'll be writing the statement first. Any two terminal linear bilateral DC network can be replaced. Okay, can be replaced by an equivalent circuit comprises of a current source parallel with the resistor. So earlier we familiar voltage source series with the resistor, but here current source parallel with the resistor. The Norton networks will be like this. There is a current source. You can see a current source. It is very clear. Current source. Then we have to connect with a resistance parallel to the current source. Okay. Basically, two terminal network. So this R10 is known as Norton resistance, Rn. Okay. So this is regarding Norton's theorem. So I think you got to understand, you have got an idea about the difference between Thevenins theorem and Norton's theorem. Now I would like to discuss about maximum power transfer theorem. According to maximum power transfer theorem, the maximum power transmitted from source to load when the load resistance is equal to the source resistance. That is called the maximum power transfer theorem. So we can draw one simple circuit. We have the source. Okay, the source is having the internal resistance. You can call it as RTH or Thevenins resistance, and this is your load. Okay, you can see the load resistance. This is your R. Okay, battery or EMF. Maximum, according to maximum power transfer theorem, the maximum power transfer from source to load when the source resistance is equal to load resistance. In AC circuit, we call it as impedance matching. Okay, so there is a condition, some conditions. So the maximum value of power, so PL maximum, that is equal to ETS square divided by 4 into R. Okay, this is actually the value of maximum power which is transmitted from source to load. Also, what is the percentage efficiency? Percentage efficiency during maximum power transfer theorem will be 50%. Okay, so likewise you can expect some kind of questions in the competitive examination. So in this session I have made an overview on Thevenins theorem, Norton's theorem, and ultimately maximum power transfer theorem. So in the coming session I am solving some numerical example based on this theorem. Let me know if you are having any doubts regarding this. You can put up in the comment box. Finally, thank you for watching this video. Happy learning.